August 17, 1943, 30,000 feet above Schweinfurt, Germany, the lead bombardier of the 230 B-17 Flying Fortresses peers through his Norden bombsight. Anti-aircraft flak bursts violently around the formation, shaking planes and rattling nerves. Below, 5 factories, responsible for nearly 2/3 of Germany's ball bearings, glimmer through breaks in the smoke. The German aviation industry consumes 4 million ball bearings every month. If this raid succeeds, the Nazi war machine could grind to a halt. But as bombs rain down and German fighters tear into the bomber formations, a starkly different story is unfolding thousands of miles away in Canton, Ohio. While American bombers fight and die over German factories, 60 B-17s lost 102 crewmen killed. That day American engineers are quietly producing something Germany cannot match: tapered roller bearings. Not only do these bearings outperform ball bearings in most applications, but they also eliminate reliance on German technology entirely. This is the documented story of how an immigrant German carriage maker in 1898 invented a superior bearing design. A design that would quietly revolutionize industry and give the Allies an advantage no bombing raid could destroy. How his company became America's answer to Germany's ball-bearing monopoly, and how that obscure mechanical innovation helped win World War II. Friction transforms kinetic energy into heat while damaging surfaces and wasting energy. It's a fundamental problem in all mechanical motion. The man who could reduce friction fundamentally, German immigrant Henry Timken believed, would achieve something of real value to the world. Henry Timken was born August 16, 1831 in Tarmstead, Kingdom of Hanover. He immigrated to the United States with his family at age 7, settling in Missouri. As a teenager, he apprenticed to a leading carriage and wagon maker. By age 24, he had established his own carriage factory in St. Louis. In 1877, Timken received a patent for the Timken buggy spring, which became widely used throughout America and produced on a royalty basis by numerous companies. The spring's success made Timken well known nationally, and his carriage business flourished. Around 1895, Timken took interest in problems created by friction in wagon design. Conventional bearings of the 19th century worked well at reducing friction under vertical loads, but encountered problems when wheels had to bear heavy loads from the sides, as when vehicles turn corners. Ball bearings, the most common anti-friction bearing of the era, used spherical balls rolling between an inner and outer race. They worked excellently for light loads and high speeds, but had limitations. When subjected to heavy radial loads and thrust loads simultaneously, like a wagon wheel turning while carrying weight, ball bearings wore quickly. Timken, with help from his 2 sons and a nephew, began experiments to make a better bearing. They developed a revolutionary concept. Instead of balls, used tapered rollers. The rollers would be cone-shaped, arranged at an angle between cone-shaped races. This geometry would allow the bearing to handle both radial loads perpendicular to the shaft and thrust loads parallel to the shaft simultaneously, exactly what vehicle wheels needed. On May 1, 1898, Henry Timken received 2 patents for his tapered roller bearing design. The innovation was profound. His bearing could handle 5 times the load of an equivalent ball bearing while maintaining lower friction and longer life. In 1899, Timken incorporated the Timken Roller Bearing Axle Company in a corner of his St. Louis carriage factory. The company grew so quickly that in 1900, one Timken decided to relocate to Canton, Ohio, to be near the emerging automotive industry centered in Detroit and Cleveland, and the steel-making centers of Pittsburgh and Cleveland. While Timken developed roller bearings in America, Germany dominated ball bearing production worldwide. In 1883, German entrepreneur Friedrich Pfizer and his son pioneered mass production of precision steel balls in Schweinfurt using a grinding machine. Their factory merged with George Schieffer's shop to become Kugel Fischer George Schieffer in 1909. Another Swedish-German company, SKF Svenskar Fabriken, founded in 1907, rapidly expanded globally. By 1908, SKF had branch offices in Germany and France. By 1909, subsidiaries in New York, then Britain, Denmark, Norway, Belgium, Holland, and Russia. SKF became the world's largest bearing manufacturer. Before World War I, most ball bearings used in America were imported from Germany. German companies had established dominant positions through superior metallurgy, precision manufacturing, and aggressive global expansion. Henry Timken's travels to Germany in 1892 and 1895 provided competitive advantages. He observed Daimler and Benz's internal combustion engine technology and witnessed advanced bearing development. Europe was years ahead of America in bearing production, but Timken's tapered roller design offered advantages that German ball bearings couldn't match. For heavy load applications, trucks, railroad cars, industrial machinery, tapered rollers vastly outperformed ball bearings. The geometry distributed loads across a line of contact rather than a point, dramatically increasing load capacity. By 1920, the Timken Company was making 90% of America's tapered roller bearings. The company operated bearing plants in Columbus, Ohio, opened 1920, Canada 1922, and would eventually expand globally. Railroad adoption was crucial. In 1923, Timken bearings were tested on streetcars between Canton and Cleveland, then on Wheeling and Lake Erie Railroad boxcars. By 1926, the Chicago-Milwaukee St. Paul and Pacific Railroad ordered Timken bearings for high-speed trains like the Burlington Zephyr Santa Fe Super Chief. When World War I began in August 1914, Germany's ball bearing monopoly became a strategic weapon. The British blockade cut German exports. American industry dependent on German bearings faced shortages, prices spiked. But American manufacturers found themselves unable to quickly substitute ball bearings because precision ball production required specialized machinery and expertise concentrated in Germany. The Timken Company, however, already had production capacity for tapered rollers, a different technology that worked better for many applications. Anyway, World War I demonstrated that tapered roller bearings could replace ball bearings in most military vehicles. Timken bearings equipped trucks, artillery carriages, and heavy equipment. Performance of Timken tapered roller bearings in WW1 military equipment made an impression on European markets. After WW1, Great Britain rose to the number 2 position in global automotive manufacturing, creating opportunities for Timken to expand European presence. The company entered international markets initially in Great Britain, France, and Germany, bringing American roller bearing technology to compete directly with European ball bearings. Henry Timken died on March 16, 1909, in San Diego, California, before seeing his invention's full impact. His sons H. Timken and W.R. Timken continued building the company. In 1917, facing World War I steel shortages, Timken began steel and tube making operations in Canton to vertically integrate and control bearing steel quality. This decision proved critical. Making your own steel meant controlling composition, heat treatment, and quality at every step. Bearing steel requires precise carbon content, uniform grain structure, and freedom from inclusions. By producing steel internally, Timken ensured bearing quality while protecting against supply disruptions. The company entered the Great Depression in strong financial position. Its performance placed it among the most solid, well-managed industrial firms of the 1930s, expanding into non-automotive markets, agriculture, machine tooling, industrial equipment, and rail softened depression impacts. During the early 1930s, Timken developed bearings for propeller drive shafts, expanding into shipbuilding, including U.S. Navy contracts. In 1932, Timken began manufacturing removable rock bits for construction and mining equipment, providing outlets for steel production during depressed markets. When H. Timken died in 1940, his son H. Timken Jr. became chairman. The company had manufacturing facilities in Ohio, Canton, Columbus, Mount Vernon, Canada, Britain, France, and South Africa. Timken employed thousands and produced bearings for virtually every industry. Then war came to Europe again. By 1943, Allied intelligence identified ball bearings as a critical German vulnerability. Albert Schar, German armaments minister, stated as early as September 20, 1942, "I had warned Hitler that the tank production of Friedrichshafen and the ball-bearing facilities in Schweinfurt were crucial to our whole effort." Schweinfurt in central Bavaria hosted 4 ball-bearing manufacturing complexes that collectively produced about half of Germany's total ball-bearing output. Kugelfischer Georg Schiefer, the largest complex north of the main railard, employed 700 workers, even at war's end in 1945, plus slave laborers. Fichtel and Sachs southwest of the rail yard, a subsidiary of SKF Vereinigt Kugellager Fabriken IVKF, 2 factories VKF Work, 1 in city center VKF Work, I-2 south of Railard, also an SKF subsidiary. The U.S. 8th Air Force planned a German war production by destroying these factories. British Air Marshal Arthur Harris dismissed ball bearings as panacea targets, claiming RAF bombers couldn't find a town Schweinfurt's size at night, much less hit specific factories. But the USAF was committed to daylight precision bombing. On August 17, 1943, 376 B-17 took off to attack Schweinfurt and Messerschmitt factories at Regensburg. The mission was catastrophic. Of 230 B-17s attacking Schweinfurt, 36 were lost, 7% of the force. Combined with Regensburg losses, 60 B-7s were destroyed that day. Of 101 crewmen lost, 102 were killed, 381 captured, others evaded or were interned. B-7 gunners claimed 288 German aircraft destroyed. Actual Luftwaffe losses 25 to 35 fighters, but the bombing worked temporarily. German ball-bearing production dropped from 140 tons in July to 69 tons in August and 50 tons in September, a 64% reduction. The second Schweinfurt raid came October 14, 1943, Black Thursday. This time 60 of 229 attacking B-17s were lost, a 26% loss rate. Total casualties 594 MA 40 WA 5 KA. Such losses were unsustainable. Albert Schar later admitted that if the Allies had concentrated on bombing ball bearings, 2 months later it will weaken war production fundamentally, and 4 months later the war production will stop completely. But they didn't. The raids were too costly. Deep penetration missions without long-range fighter escorts resulted in catastrophic losses. Schweinfurt raids were halted until P-51 Mustangs with drop tanks could escort bombers all the way to targets and back. Despite devastating raids, German ball-bearing shortages never crippled war production. 3 factors prevented collapse. First, stockpiles. Germany had accumulated enormous reserves of ball bearings. Factories maintained months of inventory as buffers against disruption. Second, import. Germany imported ball bearings from neutral Sweden and Switzerland. Swedish SKF supplied approximately 10% of German needs through 1943, increasing as domestic production fell. Bearings were small, valuable, easy to smuggle. Boke Mosquito aircraft flew dangerous missions to Sweden, returning loaded with ball bearings purchased by Allied agents. British and Americans eventually pressured Sweden to reduce ball-bearing exports to Germany. In April 1944, the Allies negotiated directly with SKF, offering to pay the equivalent of 88 million kroner to end deliveries to Germany. OSS agents infiltrated SKF Gothenburg plant, monitoring shipments. But by then, damage was done. Swedish bearings had sustained German production through critical periods. Third, substitution. Where possible, German engineers redesigned equipment to use plain bearings, sleeve bearings, bushings instead of ball bearings. Plain bearings require more frequent maintenance and replacement, but can be manufactured with simpler technology and less critical materials. Post-war analysis confirmed Arthur Harris's skepticism. The ball bearing campaign, despite costing hundreds of American lives and dozens of bombers, achieved limited strategic effect. By 1945, Germany had assembled more bearing reserves than ever. Production dispersed to underground facilities and smaller shops, making targeting ineffective. While B-17s burned over Schweinfurt, American factories were solving the bearing problem differently, not by bombing German factories, but by producing alternatives that worked better. When World War II began, Timken's production increased dramatically. The company opened several new Ohio facilities. Timken Ordnance Company in Canton 1941 built approximately 80 0.00 gun tubes over the next 2 years. The Zanesville bearing plant opened in 1943. Other new locations included Columbus and Newton Falls. During the war, Timken's output more than doubled its previous peak. The statistics tell the story. Every U.S. Jeep used 24 Timken bearings, with 660 0.00 Jeeps delivered to the military. Timken produced over 8 million bearings for Jeeps alone. Trucks required dozens more bearings each. Tanks used Timken bearings in tracks, wheels, turrets, and transmissions. Artillery pieces, aircraft landing gear, ship propeller shafts, all used Timken tapered roller bearings. The advantage wasn't just that Timken bearings worked. They often worked better than ball bearings for military applications. Load capacity. Tapered rollers handled combined radial and thrust loads far better than ball bearings. Tank tracks and truck wheels experienced exactly these combined loads. Durability. Line contact between roller and race versus point contact in ball bearings, distributed loads reducing stress and extending life. Maintenance. Tapered roller bearings could be adjusted to compensate for wear. Ball bearings once worn had to be replaced. Manufacturing. Timken controlled its entire supply chain from steel production through bearing assembly, no dependence on imports or external suppliers. By war's end, Timken had produced hundreds of millions of bearings for Allied military equipment. The company's vertically integrated model, making steel, machining bearings, and controlling quality end-to-end, proved superior to relying on global supply chains that wars disrupted. The physics favoring tapered roller bearings weren't obvious, but were fundamental. Contact mechanics. A ball bearing contacts its race at a point. Under load, this point deforms into a small ellipse, but contact area remains tiny. Stress concentrates intensely. A tapered roller contacts its race along a line. Under load, this line deforms into a narrow rectangle. Contact area is much larger. Stress distributes over greater area, reducing peak stress. Load distribution in ball bearings. Under combined loads, only a few balls carry most of the load. In tapered roller bearings, all rollers share loads more evenly due to geometry and precise positioning. Adjustability. Tapered roller bearings can be preloaded, adjusted to eliminate clearance and optimize contact. Ball bearings have fixed clearances determined during manufacturing. Heat dissipation. The larger contact area in roller bearings conducts heat away more effectively, reducing operating temperatures. For military vehicles operating under harsh conditions, shock loads, heavy weights, poor maintenance, contaminated environments, these advantages were decisive. Timken bearings survived conditions that destroyed ball bearings. German engineers knew tapered rollers existed, but their manufacturing was concentrated in ball bearings. Converting production would require retooling factories, retraining workers, and redesigning equipment. Impossible during wartime. Following World War II, much machinery shipped to Europe under the Marshall Plan was equipped with Timken bearings, helping the company establish broader presence in markets where European competitors had dominated. The antitrust case that haunted the company, United States v. Timken Roller Bearing Co., came to head post-war. The Justice Department alleged Timken conspired with British Timken Limited and French Timken to restrain trade through territorial restrictions. During the war, these restrictions created problems. Australia in British Timken territory desperately needed bearings for war production. British Timken couldn't supply adequate quantities. They were overwhelmed meeting UK military needs. Australian distributors clamored for American Timken bearings. December 4, 1940, correspondence between Timken executives showed the dilemma. We were advised by the British Purchasing Commission that they will very likely take over all purchases of anti-friction bearings for Australia. They will give business to the lowest bidder. Internal memos documented how Timken navigated territorial agreements during wartime. There was a serious interference in Australian war production due to British Timken's inability to supply bearings for the period of the war emergency. Defendant was permitted at first to fill only Australian orders and later orders emanating from any place in British Timken's territory, but only through British Timken's distributors and only at prices designated by it. After several appeals, the Supreme Court ruled in 1951 that Timken had conspired with foreign affiliates in restraint of trade. The decision forced restructuring of international operations, but didn't slow Timken's growth. By 1960, Timken operated in the U.S., Canada, Great Britain, France, South Africa, Australia, and Brazil. In 1974, Timken opened sales operations in Japan, bringing American tapered roller bearings to compete in the world's most demanding bearing market. Throughout the 1970s and 1980s, Timken expanded into Italy, Korea, Singapore, and Venezuela. In 2003, Timken acquired competitor the Torrington Company for $840 million, doubling company size and creating the world's third largest bearing manufacturer. In 2014, the company separated bearing and steel operations. Timken Company continued manufacturing bearings while Timken Steel, now Metalese, became independent. As of 2024, the Timken Company posted $4.6 billion in sales and employs more than 19,000 people globally, operating from 45 countries. Timken remains the world's largest manufacturer of tapered roller bearings, a position held continuously since the 1920s. The product line has expanded. Timken now manufactures ball bearings, spherical bearings, cylindrical bearings, thrust bearings, plain bearings, housed units, and precision bearings. The company produces gear drives, automated lubrication systems, belts, chain, couplings, linear motion products, and power transmission services, but tapered roller bearings remain central. From bearings the size used in disc drives to the 9-ton custom bearing made for a heavy forge, Timken dominates the market with approximately 30% global market share in tapered rollers. The ultimate irony is that Henry Timken was a German born in Hanover. He immigrated at age 7 and became thoroughly American, but his engineering sensibility reflected German thoroughness and precision. His trips to Germany in the 1990s exposed him to European bearing advances. German ball bearing manufacturers like Pfizer and Schiefer pioneered precision manufacturing. Swedish SKF created global distribution networks, but these companies focused on ball bearings because that's what they knew. Timken saw what established manufacturers didn't, that for heavy load applications, rollers beat balls. The tapered geometry he patented in 1898 solved problems that ball bearings couldn't. When World War II came, American industry had a domestic bearing manufacturer that didn't depend on German imports, didn't require Swedish neutrality, and produced bearings superior for most military applications. The Schweinfurt raids, devastating to German production, weren't necessary to keep American war production running. Timken factories in Ohio were already producing everything needed. German Armaments Minister Albert Sh. Pierce spent the war worried about ball bearing supplies. His American counterpart didn't have that concern. Timken had it covered. Modern bearing technology vindicated Henry Timken's 1898 innovation. Today's heavy equipment overwhelmingly uses tapered roller bearings. Automotive wheel bearings in trucks, SUV, and heavy-duty vehicles, aerospace, landing gear, gearbox applications, rail, freight, car axles, locomotive drives, industrial wind turbines, mining equipment, steel mills, construction, excavators, cranes, heavy machinery. Ball bearings remain optimal for high-speed light load applications like electric motors, machine tools, and precision instruments, but for combined load, heavy-duty applications, tapered rollers dominate. The physics Henry Timken exploited in 1898 remain unchanged. Line contact distributes loads better than point contact. Tapered geometry handles combined loads better than spherical geometry. Adjustable bearings adapt to conditions better than fixed bearings. These principles, worked out in a St. Louis carriage shop, became the foundation for a global industry. While historians debate whether bombing Schweinfurt mattered, there's no debate about whether Timken bearings mattered. They were in every Jeep, every truck, every tank track, every propeller shaft. The tapered roller bearing won no headlines. It appeared in no dramatic photographs. Generals didn't discuss bearing strategy at Yalta or Potsdam, but logistics officers knew without bearings, vehicles don't move. Without movement, armies can't fight. Germany entered World War II dependent on centralized ball bearing production, vulnerable to bombing. America entered World War II with dispersed, tapered roller bearing production, immune to attack. Germany spent the war scrambling for Swedish imports and substituting inferior plain bearings. America spent the war producing superior bearings in unlimited quantities. The advantage wasn't dramatic. No single battle turned on bearing supply, but aggregated over millions of vehicles, billions of operating hours, and 6 years of war, the cumulative advantage was enormous. Every bearing that didn't fail meant one less vehicle disabled. Every vehicle operational meant supplies reached the front. Supplies at the front meant offensives continued. Continued offensives meant victory. Henry Timken died in 1909, never knowing his invention would help win the greatest war in history. He just wanted to build a better bearing for wagons. He succeeded beyond imagining. The immigrant from Tomstad, who apprenticed as a carriage maker at 16, invented something of real value to the world, exactly as he'd intended. The tapered roller bearing reduced friction fundamentally. It still does, and while American bombers died over Schweinfurt trying to destroy German ball bearing factories, American factories quietly produced something better, not through dramatic raids or strategic bombing, but through patient engineering and mass production. The bearing war was won not in the skies over Bavaria, but in factories in Canton, Ohio, where German-born Henry Timken's invention, perfected by his American company, rolled off production lines by the millions. America didn't need German ball bearings in 1940.